Welcome, class, to the Intro to Java Programming. In this lesson, we will review polymorphism, one of the major building blocks to object-oriented programming. Object reference polymorphism will be the focus along with some visual and code examples. Object-oriented programming is about creating objects that contain both data and methods. The four building blocks for object-oriented programming are encapsulation, inheritance, abstraction, and polymorphism. In this lesson, we'll focus on polymorphism. Polymorphism means existing in many forms. With the use of contracts, overloading, and overwriting, we can enforce simplicity, which helps make the code more extendable and easier to maintain. It lets programmers use the same word to mean different things in different contexts. Yes, this definition is a little vague until you better understand the true meaning. Polymorphism means existing in many forms. Specifically, classes and methods can exist in many forms. Let's review the three types of polymorphism. Dynamic polymorphism, often referred to as method overriding or runtime polymorphism. Static polymorphism, often referred to as method overloading or compile time polymorphism. And finally, object reference polymorphism. This lesson will focus on object reference polymorphism. Object reference polymorphism is achieved when using inheritance with a class, abstract class, or interface. Object reference is the ability to refer to a child class by using the parent class reference. Let's say there's a monster and a goblin. The relationship between these two could be with a class, an abstract class, or an interface. For this example, all three relationships apply. Assume there are no compiler errors with the monster and the goblin. Let's add another relationship with monster and skeleton. Goblin and skeleton will have unique code but share common code found in monster. Let's imagine there is a game control class and there is a variable called monster. The data type used is a monster class or interface, and it instantiates a new goblin class. Object reference polymorphism is accomplished when the monster variable is also instantiated with a new skeleton class. The monster variable is declared with a monster class or interface. Both goblin and skeleton are extending or implementing monster, so the monster variable can be a goblin or a skeleton. Polymorphism means existing in many forms. One object reference can have many forms. Now let's look at passing an object reference as a parameter to a method. Here are two variables, monster as a new goblin and goblin as a new goblin. Remember, goblin is related to a monster using inheritance of a class, an abstract class, or an interface. Imagine there is a method called getMonsterName. The method will return a string and accept one parameter as a monster data type. The variable name monster can be passed to the getMonsterName method. Both are the same data type, a monster. Time for a Coach Joe challenge question. Can the variable goblin be passed to the getMonsterName method? It is true, the data type for the method parameter is different than the data type of the goblin variable being passed. However, they both share the same object reference, monster. The method is expecting a monster data type. The goblin variable is a goblin class, but it's extending or implementing monster. Because of this relationship, the goblin variable can be passed to the method. This is another form of object reference polymorphism with the use of parameters. Now let's change the parameter for the getMonsterName method to a goblin data type. Time for another Coach Joe challenge question. Can the variable name monster be passed to the getMonsterName method? The short answer is no. Object reference polymorphism does not work that way. Think of it like this. A goblin can extend or implement a monster, which makes a goblin a monster. A monster does not extend or implement a goblin, so a monster is not a goblin. A monster is a monster. So passing monster to the getMonsterName method will be a compiler error. The variable goblin can be passed to the getMonsterName method. Both are the same data type, a goblin. Please note, passing a goblin data type is not object reference polymorphism. Only if the parent or interface object is used as a parameter will it be considered object reference polymorphism. Goblin is not a parent or interface to another class. Goblin can be a parameter, it's just not polymorphism. Polymorphism means existing in many forms. As you can see with these examples, one object reference has many forms. Let's look at the code for polymorphism. Open the OOP intro project in IntelliJ, close any open class tabs. Create or navigate to the polymorphism test package. Let's create a new class called Object Reference Polymorphism Test. This first test will pass a parent interface object as a reference to a method that expects a parent interface object. Here, the monster polymorphism interface object is declared with the variable name monster. Monster is first set to a new Goblin polymorphism interface object. The string variable actualMonsterName will hold the results of the getActualMonsterNameByInterface method call. The monster variable is passed. Looking at the private method, the only parameter is a monster polymorphism interface object. Here the value of getMonsterName is returned. Back in the test, the assert will test the result. Next, the monster variable is set to a new skeleton polymorphism interface object. Again, the string variable actualMonsterName holds the results of the getActualMonsterNameByInterface method, and the assert tests the result. This test will show passing a child class object to a method that expects a parent interface object and to another method that expects a similar child class object. The Goblin variable is set to a new Goblin polymorphism interface object. ActualMonsterName will hold the results of the previous getActualMonsterNameByInterface method. The assert will test the results. Then ActualMonsterName will hold the result of the getActualMonsterNameByGoblin method call. The assert will test the results. And here is the getActualMonsterNameByGoblin method. Notice the parameter is a Goblin polymorphism interface object. The value of getMonsterName is returned. This test is similar to the previous test except skeleton polymorphism interface is the object used. The skeleton object is passed to the getActualMonsterNameByInterface method. It is passed to a new method called getActualMonsterNameBySkeleton, and it is passed to the getActualMonsterNameByGoblin method. This method call will generate a compiler error because the parameters do not match. Here is the new getActualMonsterNameBySkeleton method. GetMonsterName is returned. This test will show passing a parent interface object as a reference to a method that expects a child class will generate a compiler error. Here, the monster polymorphism interface object is declared with the variable name monster. Monster is set to a new skeleton polymorphism interface object. The string variable actualMonsterName will hold the result of the getActualMonsterNameBySkeleton method call. Passing the parent interface object to a method that expects a child concrete class is not allowed. A compiler error will occur. The next 4 tests will show the same object reference examples with the abstract class. Here are those tests. And the last 4 tests will show the same object reference examples with an inheritance class. Here are those tests. Let's navigate to the polymorphism package. The remaining classes might exist from a prior lesson. If not, let's create them now. Create a new class called Monster Polymorphism Interface. There is one abstract method. Create a new class called Goblin Polymorphism Interface. This class will implement the Monster Polymorphism Interface. There is only one overridden method. And create another new class called Skeleton Polymorphism Interface. This class will implement a monster polymorphism interface, and there is one overridden method. These 3 classes are used for the interface test examples for polymorphism with object reference. There are 6 other classes that are needed. For the abstract class examples, create a new class called Monster Polymorphism Abstract. Here is the code. Create a new class called Goblin Polymorphism Abstract. Here is the code. Create a new class called Skeleton Polymorphism Abstract. Here is the code. For the inheritance class examples, create a new class called Monster Polymorphism Inheritance. Here is the code. Create a new class called Goblin Polymorphism Inheritance. Here is the code. And create a new class called Skeleton Polymorphism Inheritance. Here is the code. Let's go back to the test class. There should be 6 compiler errors. Here, a skeleton child class is being passed to a method that expects a goblin child class. Both child classes have the same interface, but the method is only looking for a specific child class. Let's comment these lines out. Here, the parent interface object is passed to a method that expects a child class. Even if that child class implements the parent interface, the object cannot be passed. Let's comment out this test. These 2 errors are similar to the ones above. And these last 2 errors are similar to the ones above. Comment out this line. And we'll comment out this test. Let's run all 9 tests for this class. And they pass. Here's a summary of all the test code we wrote for this lesson. You should now have an understanding of object reference polymorphism. Visual and code examples were provided to show how one object variable can be instantiated with several other objects, provided they are extending or implementing the class. Object reference polymorphism also applies to passing an object variable to a method as a parameter. Polymorphism means existing in many forms, and the use of object reference polymorphism is one way it can be accomplished. In the next lesson, we will review a summary of object-oriented principles. Remember, future senior developers, make it work, prove it works, then make it better. Ready? Break!